Okay, so we're recording just in case. I think we're missing like 10 people now. I can post this later. All right, but we'll get rolling. So here's an example of, once again, this is in standard form. It says 2x plus 3y equals 12. And then I have it already graphed out. It's that red line. It's a little hard to see, and this should have arrows on it just so you can see it. Okay, now a few things you should notice why those points are highlighted. So we see the point 0, 4, we see the point 6, 0. Does anyone know what's special about those 2 points? What is special about 0, 4? What is special about 6, 0?
0, 4 is the y-intercept and 6, 0 is the x-intercept.
Good. And we've used the y-intercept with slope-intercept graphing, right? We haven't really used this one before, but Ashton correctly describes that, hey, that's the x-intercept, where it's where the graph hits the x-axis. The other point is where the graph hits the y-axis. This is how standard form graphing works. Standard form graphing actually only involved you plotting 2 points. And remember, we can technically make a line using 2 points. It's not ideal, and even with slope intercept, I usually say like, hey, make a few more, do 3 or 4. This way you could connect the dots a little bit easier. But with standard form, you're literally only doing 2 points and then using obviously a straight edge to connect them. And what else is special, and the reason why I gave you the numbers in the equation up there, the significance of the numbers 4 and 6. So 4 was the y-intercept and 6 was the x-intercept. Now those weren't featured in the equation, but let's say for the x-intercept, if I were to cross this off, pretend it's not there for a second, this equation would say 2x equals 12. And the solution to that, if I divide both sides by 2, would be 6. And now let's go to the other side. Let's pretend the x component isn't there. I'm just covering up because the whole, hey, let's pretend it's not there. You wouldn't actually like do this if you were solving this. It says 3y equals 12. So if I were to solve this equation, I would get y equals 4. So basically, for you to find the intercepts, the x and y intercept, it's not going to be like slope intercept form where we like just look at it and pick it out. It involves a little bit of solving and this kind of idea of pretending that the other variable isn't there. And the reason why we're pretending that it isn't there, think about what the value of the other variable is at an intercept. Those are confusing sentences. Think about what the value of the other variable is at an intercept. An x-intercept is always going to have a y value of 0. A y-intercept is always going to have an x value of 0. So that's why I'm saying pretend that the other variable isn't there. Because if you plug in a 0, what happens? It basically goes away. Not great math terminology, but when we plug in a 0, for all practical purposes, that variable is no longer there. And this is how we're going to graph. So I have the steps a little bit more formally written out. And I have a big or here because it's not like you have to do this. No one's ever going to pressure you like, hey, do this only using standard form. So I'll get to the or second. But basically, just summing up what I just said on the last slide, we're going to find the 2 intercepts. You find the x-intercept by plugging in a 0 for y. You find the y-intercept by plugging in a 0 for x. And that's because what we just mentioned, the other coordinate is always 0 when it hits that axis. And then it's solving like a one-step equation. Like we saw 2x equals 12 or 3x equals 12, just taking a second to solve that little mini equation. You're going to plot the 2 points and connect with the ruler. That's what a straight edge is. Like I said, there are cases where this could work out if you're like, this seems really confusing and I hate it. There are cases where this can work out to be a little bit more convenient. And now the or on the bottom there. Let's say you gave it a chance, you've been doing it, and it's really not connecting for you, you don't really like it. You do always have the option of making the equation into what we've been doing so far this week. You can rewrite it in y equals form and then use your m and b stuff. Just explaining what I mean there. What was that last example? 2x plus 3y equals 12. So let's say we had that same equation and I don't feel like doing standard form, I can just take this and get it in y equals form. So I would subtract 2x from both sides. And then I would divide by 3. So it's not like you ever have to do this. You can always mold it a little bit differently, and then we'd write down our m and b values. So this would be -2/3 and +4. And then we could graph it that way. And it's going to end up being obviously the exact same line. It's not like if you use a different technique, you're going to get 2 different lines. All right, I'll pause for a moment. Any questions so far? Kind of makes more sense when we actually do a full one. Might still seem a little confusing, but any questions so far?
When you say connect points with straight edge, like what points are you talking about?
So the two, oh yeah, because technically I guess it doesn't say plot. So in 1 and 2, let's say I know that x-intercept is at 1, and then I know, I'm just making these up, the y-intercept is at 2. So technically for steps 1 and 2, pretend that it said like plot, find them and plot them. So once you have those 2 intercepts, then you're going to play connect the dots. Okay, so you're just plotting the 2 intercepts and connecting them.
Okay.
It should, if you want to add the word find and plot. Sorry about that. All right, and let's try one. So you could just watch if you want for this one. If you're sitting there with a paper in front of you and you feel, if you feel pretty confident, or if you want to try it with me, you want to just watch, all those things are cool. So this is in standard form right now. So we could do some maneuvering and make it in y equals. That might be a little bit more work since it's already in the form that we could actually do something with it. So I'm going to find the 2 intercepts, and I'll show you how I like to organize my work for these. So I make a little like T-chart almost, just to separate the two. And I call it like x-intercept on the left, y-intercept on the right. So remember, for the x-intercept, the y value is 0. And for the y-intercept, the x value is 0. Kind of think about this idea of like the opposite one is 0. So now if we take that equation and instead of y, I write 0. And I'm going to do the same thing, not the same thing, but same idea on the right. And remember, I'm plugging in a 0 here because that's the value at that particular intercept. The y-intercept always has an x value of 0. The x-intercept always has a y value of 0. Now I can do the math here. Like we said, it kind of goes away, right? Plugging in a 0 doesn't really do anything else. And now I'm going to solve these little equations. So on the left, I should get x equals 5. And on the right, I should get y equals -4. Now, don't confuse that. That doesn't mean this is a coordinate 5, -4. These are 2 different points. So one point that we found is 5, 0. And the other point that we found, be careful, is 0, -4. That's the y value. So now I'm going to plot 5, 0. X-intercept, it makes sense. It's on the x-axis, right? And secondly, I'm going to plot the y-intercept. 1, 2, 3, 4. Makes sense. It's on the y-axis. Now that I have 2 points, I'm going to connect them with a straight line and put arrows on either end, as always, to indicate that, hey, this relationship continues on. And I'll label it. And that's it. And once you get a little, same thing with, like we've done with tables and mx plus b, once you get more comfortable with it, you kind of end up skipping over like this step, and you can almost do these mentally. You could just kind of look at the equation and be like, all right, I know x is 5, and pretend that this wasn't here, so y would be -4. You could end up doing these pretty quick. I know it does seem like a lot of work for now, but I'm kind of showing every single step along the way. You don't have to go through the motions of like showing the 0 being plugged in. And questions, comments, concerns so far?
I just like don't understand it.
What don't you understand?
I don't know. It's just like really confusing, like with all the steps.
Okay. So let's break it back down to the beginning. So standard form involves plotting 2 points. Those 2 points are the x and y intercept, right? So it involves just basically using the intercepts to complete a graph. There's no slope, there's no table of values. It's just using the 2 points, the 2 intercepts. Now, intercepts are pretty easy to find because you're basically going to take this equation that has 2 variables in it. And if you want to find a particular intercept, let's say I want to find the x-intercept, you're always going to plug in a 0 for y. If you want to find the y-intercept, you're always going to plug in a 0 for x. And then you should get to this stage. You should get to where it's like 3x equals 9, 8y equals 16, a one-step equation which you can then solve. When you get x equals 5, that's telling you the x-intercept. When you get y equals -4, that's telling you the y-intercept. So the whole point of that work on the left is basically just coming up with those 2 coordinates, those 2 points. And I understand it is a little confusing at first, but we'll keep doing a little bit more practice. As long as you kind of have the main gist of what's going on, that's important for now. And let's do this before we even try another graph.
Also, for like the attendance thing, I think you didn't like put the thing that we could type on it. Like, yeah.
Let me see. Hold on. The attendance thing. Oops, you're right. Yeah, it's not a big deal. There wasn't an actual question anyway. I'm just, in a second when I give you guys a practice, I'm just going to take note of who's here and who's not here. I'll leave this up. Don't even worry about graphing this one. Let's see if we can find the 2 intercepts. So don't even do the graph. Just try to find the x and the y intercept. Well, let's say it looks like this. Say 3x minus 5y equals 30. So tell me what the x-intercept is, and tell me what the y-intercept is. Take a minute to do that. And let's just gauge who's not here. Okay. This is really annoying. It puts your first name instead of your last name. Okay. Ava, is Ava here? No. When, how?
Oh, Angela's not here either.
Thank you. Ava, when, how? Brendan's here. Fatima. Emily. Yalitza, no. Where are all these people? Sleeping?
Angela probably is.
Sleeping, it's like 10:30. I told Wenhao to come. Wenhao's probably playing video games.
We're playing Clash Royale.
Gavin.
Uh,
Sophia. Man, I'm missing a lot of people. Sarah's here. We're missing both Sophias. Sophia Q and Sophia. Okay. I think I have everyone. All right. So, sorry if I was cutting off your screen. Can anyone tell me the x-intercept they found and the y-intercept that they found for the one in blue? What's the x-intercept? What's the y-intercept? Either or. Anyone.
Wait, are those like the points?
That's in blue?
Like where you would graph it?
Yeah.
Oh,
We're not
okay.
actually graphing this one. We're just trying to practice finding the intercepts.
Okay, so I got, for the x-intercept, I got 10, 0.
Good.
And then for y, I got 0, 6.
One slight mistake.
Oh, wait. No.
So pretend that x isn't there. This
Okay.
says negative 5y equals 30, right? So what would the solution to that be? Not 6, but like if I was solving this, you wouldn't get 6, you would get 30 divided by negative 5. Anyone?
-6.
Negative 6. Thank you.
Thank you.
So just the sign. Okay. And now if we were graphing this, I know I said we weren't, but if we were graphing this, I would plot this point. I would plot 10, 0. I would plot 0, -6. And then I would just simply connect the dots. If it helps, if this is how you want to think about finding intercepts, if you don't like the actual like plugging in 0 part, just think about covering up the other just think about covering up the other coordinate. So like solving that equation and then solving that equation to get your 2 values. If you'd rather do that, don't obviously like actually cross off like numbers on your page, but just that visualization could help. All right, let's try another actual graphing one. So once again, this is in standard form. I guess technically x usually comes before y. I'm just going to do that. That's not a big deal. That's a commutative property, right? I can switch the order that I'm adding. But it is in standard form because we have x and y on one side and the number on the other. This is compared to y equals mx plus b, which is just like y by itself. Okay. So let's find our 2 intercepts for this one. And we're going to plot them. X-intercept. The x-intercept would be if y were to go away, because I'm plugging in a 0. What would the solution to that be? 4x equals 24, you would get x equals. If 4x equals 24, you would get x equals 6. Very good. Whoever said that. And then pretend x isn't there. What would the solution to this be? 3y equals 24, you get y equals 8. I like to actually write these as coordinates. You don't have to, but I like to do this. Hey, 6, 0 and 0, 8, just so there's no confusion. Some people end up like plotting 6, 8 or something. So I'm going to plot 6, 0, 6. I'm going to plot 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. And now you definitely need a ruler with standard form just because you can see I even have a tool and it's hard for me to make a straight line. I don't like that. Just because it's so hard to connect 2 points if you were doing this freehand. Whatever. So if you were actually like graphing these, you definitely would want to use a ruler. I put arrows on both sides and can't hurt to label it. And that's it. Now what I want to do is let's compare how this would be if we did slope-intercept form. Because once you get the hang of this, I know it still seems like kind of annoying, but this is actually pretty quick once you get a little bit more comfortable. Why can't I shrink that? This actually gets pretty quick when you get more comfortable with it. Let's see how it would work if you were doing mx plus b. I think someone has their mic on, guys. So if I was doing this using standard form, slope-intercept form, what I would do is subtract 4x from both sides. I would divide both sides by 3, and I'd get this, right? And now m would be -4/3, b would be +8. I would begin at 8, which is our y-intercept. Both standard and slope-intercept form utilize a y-intercept, right? And then I'm going to move down 4 over 3. Down 4 over 3. So you can see it ends up actually being, obviously, the exact same line. Just a little bit different. And this is always in your back pocket. You can always just stick to slope-intercept form. Obviously, I'm just showing you another strategy that can be useful. And it depends on the situation. If you gave me this equation, like me personally, I would use standard form. If you give me one that's close to being or is in y equals, I'm going to use slope-intercept form. Basically, like you have to gauge the problem that you're given and decide what would be the most efficient. You're not just always going to use the same tool. Just like you're not always going to use a screwdriver to fix every time something breaks in your house. You're going to use the best tool, right? And yeah. Any questions with the actual graphing part?
No.
Okay. And one last thing I want to do here, kind of related to what I just did with that last problem. Pretty much place to 0 after x. Yep. You don't have to do that. You don't have to write it as coordinates. Technically, if you say the x-intercept is 6, you should be able to graph that. And if you say the y-intercept is 8, you don't have to write them as coordinates. I just like to do that. You don't have to do that, though. Converting between forms. So I was trying to, I don't know how to make this table otherwise, but this is what I really meant. Like, hey, if that's in slope-intercept form, what would that look like in standard form? And vice versa on the bottom. Hey, if that's what it is in standard form, what would that look like in y equals mx plus b? So let's start with the top row here. If you want to copy this like little table and however you want to write it, we're going to basically change it to, not that it's a new equation, but that it looks different, but it's really the same thing. And a math word for that is what we call equivalent. So we're not changing it, we're just changing the way it looks. We're not changing its value, I should say. Okay, so what I'm going to do is I want to take the x and bring it to the other side. So I'm doing this one, just so you can see what I'm doing. So I'm going to subtract 2/5 x from both sides. So we're already pretty close to being in standard form. You might say, hey, isn't that already in standard form? You have x and y on the same side together. So once again, all I did was subtract the 2/5 x. Because remember, standard form looks like this. Standard form has x, y, and then like the number on the right. So the only kind of nitpicking thing about why this is in standard form, when you write something in standard form, a and b are traditionally, and c, I suppose, a, b, and c are traditionally integers. So negative 2/5 is not an integer. So what we can do here, seems a little weird, but we're going to multiply this entire equation by something to make it so it's no longer negative 2/5, but it's an integer. So what we're going to multiply by is 5. Let's see what happens. When I multiply negative 2/5 by 5, I get negative 2x. When I multiply y by 5, I get positive 5y. And when I multiply negative 3 by 5, I get negative 15. So once again, what I did here was make an equivalent version of it. I multiplied everybody by 5. These guys were technically okay, but I still had to do it to keep it balanced. I didn't want this negative 2/5 in there. So why I chose 5, if there's a denominator of 5, multiplying by 5 is going to make that cancel out. And now we have our standard form version. So negative 2x plus 5y equals negative 15 is y equals 2/5 x minus 3 in standard form. So basically to convert that way, you're just going to bring the x to the same side. And if there is a fraction, multiply by that denominator just to cancel it out. The only exception is everybody has to get hit with the times 5, even the values that didn't need it. Okay. And then last one, the bottom row. A little bit easier here. If I want to take that from because you've kind of been doing this, if I want to take this from standard form to slope-intercept, I want to get y by itself. Slope-intercept should look like this. So what I'm going to do is move the 2x to the right now by subtracting it. That subtract 8y is now kind of like a negative 8y. I like to put the x first because that's kind of the traditional form that we have. And now I just have to divide by negative 8. I like to split it up. You could put kind of one big bar on the right. Negative divided by a negative. And 2/8 I can write as 1/4. You don't have to, but it's a good idea to simplify. And then 16 divided by negative 8 is -2. And that's it. So if you look left to right here in this table, these are actually, they look nothing, they don't really look like they're the same, right? If you look left to right, these are the exact same graphs. So the first row, even though they look totally different, if you were to graph each of those, you'd have the same line twice. You'd have the one line on top of itself. And same thing with the bottom row. Just showing you this relationship between one form and the other. I think the bottom row is a little bit easier because you've been doing this, getting y by itself. For the top row, that's really the new part. Just bring the variables to one side. And like I mentioned, if you do have a fraction, multiply by its denominator to get rid of it. And that's it. That's everything I have. Any questions with anything we covered? Any questions with this slide? Any questions?
That was confusing.
Yeah.
Which part?
Yeah.
We could do another one.
The
top row, the
think-
bottom row?
I think the top row was harder than the
Okay.
bottom.
We'll do another
Yeah.
quick one of the top. So, So, jot this down with me. Okay. So right now, this is in what type of form?
Y equals 4.
Yeah.
Intercept form.
Good. Slope
Yeah.
intercept y equals all, same thing. Very good. So, and you wouldn't like do this for fun or something, but let's say you're asked to like convert this. Like, hey, take this from slope intercept and write it in standard form. That's what we're really trying to do here. So what I want to do for standard form is basically get the variables on this. That was like the first note that you copied down earlier. We'll just drag it down here. This is what standard form looks like, right? X and Y on the same side together, and then like the number on the right. So I want to take this piece and bring it to the left. So how can I do that? Good. I'm going to subtract 1/3 x here. So that's basically washing it, right? And then I'm going to do the same thing on the left. So now I'm going to rewrite it. Negative 1/3 x plus y equals -6. Now, technically, I guess you can consider it is in standard form. Standard form just can't have any fractions in it. So when you write something in standard form, you want just like integers. You want it to say 2x plus 3y. You don't want fractions in it. So how we can get rid of the fractions is by multiplying by some number. And you're not just going to choose a number randomly. If you have a fraction, you can multiply by the denominator to get rid of it. So what would be a good number to multiply this equation by?
3.
3. If you multiply this entire equation by 3, let's see what happens. The negative 1/3 is going to become -1. Just 1y is going to become 3y. And the -6 is going to become -18. Basically, everyone gets multiplied by 3. And the whole purpose of choosing 3 was this cancels. 3 divided by 3 is 1, right? So the denominator cancels out. And that would be our standard form version of that purple equation that we started with. So move the x to the other side and then multiply by the denominator if there is a fraction. If there's not a fraction, you don't even have to worry about that. I was kind of going over like the hardest possible case. Does that make a little bit more sense, Tristan, and a few other people that said it, and rightly so, it was confusing.
Yes.
Yeah.
Yeah.
I have a question.
Sure.
So basically, when we get up to that blue step, we always have to multiply by the denominator.
If there is a fraction. If there wasn't a fraction, then you wouldn't have to worry about it. But yes.
Oh, okay.
Make sense?
Yeah.
Because think about it. If you have like, let's say you have 2/5 and you wanted to get rid of the idea that it's a fraction, what would you multiply this by? You'd multiply it by 5, right? Reason being, 5 divided by 5 kind of cancels out. So anytime you want to rid a fraction, you multiply by its denominator.
Okay.
Got it?
Yeah.
All right, cool. All right, guys. So like I said, if this was like super confusing to you, still give it a chance. There are cases where standard form does work out to be more convenient. It is one of those things that like is a hard sell once you learn mx plus b, but there are cases where it can work out to be a little bit faster, a little bit more efficient, but it's never going to really be required. So if you're really panicking based on the past half hour, you can always do M and B if you really like that, but just trying to show you all the different techniques that can be used. And this is it. We've done table, we've done mx plus b, and this was our third and final version of using intercepts, what's called standard form graphing. Next week, Monday, we're probably going to do like a little bit of a graphing task that I've done in the past. It's kind of a cool, on the art side of an activity for people that like drawing and coloring and stuff. And you'll see what I mean Monday, and then we'll keep rolling with some new graphing stuff. But that's everything I have for this. Thank you guys for participating, the 20 or so people we have in here. And I'm going to conclude there. Any last remarks or questions?
Oh, wait. So you're going to be posting like the work that we did on here? Like all this notes
I
and
recorded this just in case people weren't here. There was like 10 people or 8 people that aren't here, so I did record it.
stuff? Okay.
If you want to rewatch it, you can do that. Yeah, even if you're
Yeah.
here and you're like, I'm still lost, you can rewatch it as well. And if you
Okay.
do talk, if someone talks to one of their friends and like, oh, I overslept, just remind them that I'll post it. I'll post all this. All right,
Okay.
guys. Have a great weekend. Everyone continue to stay safe, be well, and enjoy the weekend.
Thank you. You too.
Bye, guys.
You do.
Have a great weekend.
Bye, Brennan.
Bye.
Oh, that's why I was talking the whole thing. It's just my mic was muted.
Lol.
Okay, see ya. Follow Big Bear Brennan on Instagram.